Welcome to part 3 of this tutorial series. Today I'll show you how you can use any distribution in combination with a GARCH model. I will do so by implementing the generalized error distribution and the exponential generalized beta distribution of the second kind, which are both really useful to model returns. To add the distribution, it's really simple. You should add the logarithm of the PDF here. Then you should add the distribution to this function. You should set the initial value of the parameters in this function and the bounds on the parameters in this function. So we'll start with the log PDF of the generalized error distribution, which is also called the generalized normal distribution. Like that. It has one shape parameter. So theta 3. I'll copy the log PDF and paste it here. This uses the parameterization used in Nelson 1991 in his GARCH paper. Of course, return log PDF array. We need to import the gamma function. Now we should add this log PDF to this function. If the chosen distribution is the generalized error distribution, you should return its log PDF. With the same inputs. Now we should set the initial value of the shape parameter, and the generalized error distribution is the same as the normal distribution if the shape parameter is 2 and the tails are thicker than the normal distribution if the shape parameter is between 0 and 2. So I'll set the initial estimate at 2, but it likely will end up being lower in the estimation. The bounds on the estimated can be anything between 0 and infinity. So return an array with, like, you can go lower than this, but this will be fine. And 100, you could also do mp.infinity. And then let's check if it works. As you can see, the log likelihood value is slightly lower than that of the student t distribution, so it actually does not perform better. But you see the same parameter estimates and indeed a shape parameter lower than 2, indicating that it has fatter tails than the normal distribution. Now I'll implement the exponential generalized beta distribution of the second kind. This one has 2 shape parameters, so it will be a bit different. Log PDF, the EGB2 distribution. Again, same arguments as the other log PDFs. This one is a bit different. The P is the first shape parameter, and the Q is the second shape parameter. I'll again copy the log PDF. We need to import the digamma, the polygamma, and the beta ln function for this. Like that. And of course, return a log PDF array. Then we need to add the log PDF, the EGB2 distribution, to this function. So if distribution is equal to EGB2, return its log PDF with the same inputs. Then we need to set the initial values of the parameters. So the distribution is EGB2 return an array with 2 values, since there are 2 shape parameters here. 3 is for both parameters. Fine to start with. If they are different, this influences the symmetry of the distribution. If they both go to infinity, the distribution tends to a normal distribution. The bounds on the parameters are the same as the shape parameter of the generalized error distribution. The only difference is that we should now return an array with 2 times these bounds, such that if you have shape parameters that have different bounds, you can also set the bounds. Now we have fully implemented this distribution, so we check if it works. As we see, there is some overflow. We just ignore this. We see the negative log likelihood is 3233, which is lower than those of the other distributions. And the parameter estimates are also slightly different. So I hope you now know how to implement any distribution in this code. As long as you have the logarithm of the PDF, it's really easy to do. Thank you for watching. Please leave any questions in the comments.